Hello, everyone. Welcome to today's Link webinar. This is part of our ongoing series of live and recorded weekly webinars detailing Teledyne Marine's products and applications. We hope this finds everyone doing well and hopefully having survived at least phase one of the US elections that appear to never end. The fun continues. Before we get started, I do have just a couple of quick housekeeping items for you today. So number one, today's presentation will be recorded, and you will receive an email with a link to the recording within 48 hours. So you'll have that to download and share if you like. Also, due to the large number of attendees, everyone is going to be muted. You are in listen-only mode. However, we do encourage you to type in and submit any questions that you have as we go along, and then we'll be happy to address all of those at the end. So moving on, we're very pleased to share today's topic with you. It's given by our guest presenter, Dr. Richard Vallee from Innovasea, which now includes BEMCO. Some of you may be familiar with BEMCO. It's now part of the larger Innovasea organization. This organization has sold hundreds of Teledyne Benthos acoustic modems to deliver the ACOMs for their VR4 Underwater Modem, which is used for fish and marine mammal tracking programs. A little bit more about Dr. Vallee before we get started. He's a very impressive individual. We were just chatting before we got started here. Dr. Richard Vallee is a Vice President of Sales for Innovasea's Fish Tracking Division, specializes in developing studies for tracking wild fish stocks in both marine and freshwater ecosystems using acoustic telemetry solutions. Richard has over 30 years experience developing embedded system solutions and holds degrees in physics, electrical engineering, and business. And he actually has 5 degrees, which I was very impressed with. So I think we're in good hands today with this presentation and a very knowledgeable speaker. So with that, I'll turn the presentation over to you, Dr. Vallee.
Great. Thank you, Margot. Thank you for the opportunity to speak here as well. Really appreciate that. Thank you, everyone, for joining my talk today that will focus, as Margot says, on fish tracking using acoustic telemetry. Innovasea is focused on developing products and services for the sustainable use of our aquatic resources. And in my case, I'm predominantly involved with researchers interested in gaining knowledge for the sustainable use of wild fish stocks. So the technology really that we've developed focuses on tracking fish, individual fish, using acoustic telemetry. And we've been doing this now for nearly 4 decades. So the idea is you attach a tag to an animal. The tag transmits acoustic power, and in that information is the ID of the animal, as well as potentially some sensors, pressure sensors, temperature sensors, that sort of thing. Those transmissions are picked up by acoustic receivers, and so then you know what individual was in the range of that receiver and the date and time and any other information that was there. So this allows us to track any number of aquatic species, whether they be saltwater, freshwater, and the duration of these studies can go on from weeks and months to many years. As well, we maintain a global database of IDs for data integrity reasons that allows us to sell these transmitters worldwide, and wherever these tags go, you're sure to know that that was your particular animal that might have been detected. So over the 40 years that we've been developing these products, we've certainly seen a lot of change and a lot of development. From the early days, and with electronics and the miniaturization, we've been able to get to smaller and smaller tags and build more and more sophisticated receivers as we have been able to progress. So this kind of gives a quick snapshot of some of those developments. And today we're going to predominantly focus around the VR4 underwater, or touch on the VR4 underwater modem. When designing or planning a fish tracking acoustic telemetry study, there's a number of aspects that need to be considered. So some of those pertain around active tracking versus passive monitoring. So active tracking is when you're actually physically there trying to follow animals underwater that are, that have been tagged, versus passive monitoring, where you may tag a number of animals deploy receivers in areas that are of interest to you. Let those receivers collect data for a number of months, 6 months, 12 months, maybe several years. And then you collect that data and then analyze it and try and determine what was happening with the animals you were studying. You may also be considering things like residency or migratory studies. So a residency study would be where fish are maybe using a particular habitat and there may be a large number of individuals that will come and go, versus a migratory study where fish are either traveling downriver or upriver to spawn and you're looking at their movements, or they may be coastal animals and you're looking at their use of coastal regions, you know, on an annual basis. We can also look at fine scale positioning. So if you want to know precisely where an animal was situated within an ecosystem, you can do that through triangulation, and we can get to resolutions on the order of meters or even sub-meters, and depending on the solutions used. Or conversely, you may just be interested in presence absence. Was the animal in that area or was he not there at that particular time? And so all of these things, the spatial scale is important, either in terms of the resolution, in terms of positioning, or how large an area that you're interested in studying the animals in. So it could be a few square kilometers to a very small area. And the temporal scale is also important, both in terms of the resolution, in terms of how often you get an update for that particular animal. It could be every few minutes down to seconds, or you may be looking at studies that have durations of maybe a few weeks to several years. So in order to conduct these studies, the active fish tracking technology, we have an active receiver, which we call the VR100. It has hydrophones, either omnidirectional or directional. And this sort of shows the frequency ranges that we're working in, sort of 51 kilohertz to 84 kilohertz, or up in the 180 kilohertz range. And in terms of transmitter technology, we initially started in the early days with continuous tags. So these would be tags that each tag transmits on a different frequency, and so you're now tracking animals in, if you like, the frequency domain. And we have various sizes of tags. The V9, 9mm tag, V13 is 13mm, V16, 16mm with sensors. And again, as you tag each animal is on a different frequency. That was somewhat limiting in terms of there are only finite number of frequencies that we would use. And so in order to increase the number of animals that one could track at the same time, we developed a technology called coded tags. So now instead of using the frequency domain to differentiate the animals, we actually put all the animals on the same frequency and use the time domain. So we actually use encoding schemes such as pulse position modulation, where we can use a series of pings at a particular frequency and then decode those and extract the data. So that opened up the door to having many more IDs for individuals to track, and the size of those tags now ranges from 7mm to 16mm. And in terms of sensors, we have temperature, we have pressure, and we also have predation. The D is really for digestion. So we can actually detect stomach acid and know when the animal that you've tagged has actually been eaten by a larger animal, and now you're tracking another animal, which you don't really know who it is. In terms of these coded tags, they exist on the 6-9 kilohertz range, as well as the 180 kilohertz frequency. And 180 kilohertz tags, because the frequency is higher, we're able to get to smaller resonators. So we're down to a V5, 5mm tag, 7 and 9. And again, temperature, pressure, and predation. In terms of positioning with this technology, you're really limited to where the receiver was located. When the detection occurred, there's a GPS antenna built into that receiver, and that tells you where you were on the planet when you detected that particular animal. With passive fish tracking technology, we've got a number of receivers available. Some of them are just fully autonomous. The VR4 UWM is for wireless, so it uses Bluetooth. So underwater, it's listening for acoustic signals, the tags, the coded tags. Once you get pull it out of the water, you turn it into a Bluetooth device and offload your data. We've got a mobile transceiver. We've got networked related receivers with cables to give you real-time capability. The VR4 Underwater Modem, which we'll talk about a little bit more. The VR4 Global, which uses an Iridium satellite connection. And our latest system, which is Live, which is based on a cellular. Give you, again, near real-time information about the presence of animals in your study area. And then we have autonomous transponding receivers with the VR2TX, which has a transmitter built in with sensors, as well as the acoustic release version, the VR2AR. And those are available to, again, augment and help in the deployments. The transmitter technology here with passive is only coded tags. There are no continuous tags in use. And again, the technologies here are 69 kilohertz, various tag ranges, and we also have the 180 kilohertz family as well, which I'm not touching on here. In terms of the positioning, we can do fine scale positioning analysis. There's software available to do that and services. And again, it's allowing a detection to be picked up by 3 or more receivers in a location, and then taking that data, analyzing it, and triangulating back to where that tag was located between those receivers, sorry. So we have quite a diverse family of products, as you can see. So from acoustic transmitters, acoustic receivers, hydrophones, positioning in both 2D and 3D. A lot of the 3D is typically done using pressure sensors built onto the tag. And aqua measures is certainly the latest product that we've added. These are basically environmental loggers that can also transmit to neighboring receivers that are looking at things like temperature, dissolved oxygen, salinity, turbidity, chlorophyll, blue-green algae, CDOM, FDOM, and so on. So increasingly what's becoming popular or important, I guess, is when you're studying animals in a particular ecosystem, they have environmental cues, and knowing what the environmental factors are at that time is critical in understanding the animal behavior. So over the years, what's happened is the technology has been deployed by grassroots researchers, government scientists, and so on. And because of the nature of the technology and the fact that animals don't always do what we think they're going to do, they tend to travel larger distances than was anticipated, networks started to get created where individual scientists would start sharing their data with each other, sharing their receiver locations, and sharing their detections. And so this led to these groups that have sort of grown up, if you like, across the globe. Pacific Ocean Shelf Tracking, POST, which is on the west coast of North America. Ocean Tracking Network, it's another one on the east coast here, and so on. So these networks have kind of driven a lot of the next generation of products that we started to develop. So that brings us to the VR4 Underwater Modem. So a lot of those networks have coastal arrays where they're deploying receivers for long periods of time. And so the need was for a receiver that could basically be deployed for up to 9 years potentially, depths up to 500 meters, and provide the ability to communicate with the surface, so you don't actually have to pull it up. So we integrated into this product the Teledyne Benthos compact modem 9903 band C was integrated into the receiver. You can see that on the top. There's also 2 hydrophone towers there. There's a 69 kilohertz and 180 kilohertz tower. So they're able to detect tags that come in proximity. And then there's an external port as well. If you wanted sensors, there's an RS-232 external port that's accessible into this unit as well. And it has the ability to store up to 800,000 detections. The way you would get your data is then you would take the universal deck box on the surface from a boat, ship, put the hydrophone in the water and offload the data through the water column. And this allows you to basically go out periodically, collect your data. And a lot of these have been deployed by a number of those networks. Looking at one particular case study in and around Australia. So they have a number of receiver array lines that sort of are located around the continent. Hundreds of research, 170 researchers and growing, I suspect. This information is a little bit dated. They've done over 2,000 deployments of receivers and offloads of data, and they're up to over 65 million and growing in terms of the detections of the database that they've started to gather for this. Here's some examples of the VR4 underwater moorings on some of the lines, coastal lines, as well as one that was deployed trying to get the exact details either outside the Sydney Harbor or Bondi line and around an artificial reef. So a lot of times reefs are put in to create new habitat for fish species, and it's good to try to understand if the fish are actually using the habitat. So again, you can monitor the reefs using these receivers and tagging animals on those reefs. So that's how they were able to use the VR4. Another example we have is the ocean tracking network. In this particular case, the ocean tracking network works globally, as you can see. They have lines off of North America, Europe, Australia, South Africa, and are working collaboratively with a lot of the other networks. In particular, they have a line of 166 receivers off of Nova Scotia, Canada, here in Halifax. That 166 receiver basically goes from the shore out to the shelf. It's a 132-kilometer line, one of the longest, I believe, in the world, if I'm not mistaken. And after having sent vessels and trying to get vessel time to go out and gather that data using the universal deck box, they started to look at other solutions. And one of those was to use a wave glider with a tow body to actually go out and sail that line and gather the data. So as a result of that work, we were involved with Liquid Robotics at the time, I guess it's now Boeing, to develop a tow body. And that tow body incorporated 69 kilohertz receiver, 180 kilohertz receiver, and the Benthos modem. Sorry. The tow body basically allows the wave glider to offload VR4s as they come into proximity. So the modems start to communicate, and we start to offload the data as the vehicle sort of glides over the locations. And it's also able to detect tags as it's transiting from station to station using the onboard receivers. And that information is sent via cable to the platform on the surface, and that then information can then be relayed back to the satellite and back to the organization. So this has been deployed now a number of times across the Halifax line for gathering data, and it's greatly reduced their offload time, and it shows a tremendous promise in terms of reducing their data collection costs. They can actually have the wave glider go out several times a year and are not limited to weather or pandemics. The glider just goes off, does its thing. We're now into another project similar where we're working with Teledyne Web Research and integrating the the modem into the Slocum Glider. So again, in not all circumstances are wave and wave energy available to send vehicles out, and so in some instances having a Slocum Glider solution would be advantageous, particularly in the Great Lakes. And so we're actually working with University of Windsor and Teledyne and looking at, again, deploying this technology into the Great Lakes and using Slocum gliders to actually go station to station and offload the data that is being collected by the VR4 underwater modems. So again, the goal here is to greatly reduce the data offload time and reduce the overall data collection costs for our customers and scientists. And that's really the talk. I'm now available for questions. Thank you very much.
Great, thank you so much, Richard. That was really interesting, and Carl and I were just texting back and forth as we were both laughing. You never really thought about that you're tracking something that suddenly gets eaten, and now you're not quite sure what you're actually tracking. So yeah, that's interesting problem. So we are accepting any questions. If anyone has anything that they would like to ask, you can just type it in where you see the question bar on your dashboard there, and we'll be happy to answer any questions. And in addition to Richard, we also do have Carl Mancuso available for specific technical questions on the modems. So we'll just give everyone just a few seconds here, see if we've got anyone interested in getting some answers on some of these items. So a good point as well that in your talk, Richard, that this is pandemic proof. Some of these vehicles, autonomous vehicles getting out there, including the gliders. It's an interesting concept that I'm hearing more and more about, that you know, they just go to work every day. It doesn't really matter if they're out there.
Yeah, exactly. They don't have to worry about social distancing and ship time and being in close proximity. You send these vehicles out. Obviously, they have to be deployed, but once they're deployed, then yeah, they can go out and do a lot of that work. Put less people in danger.
Yeah, and that really is what it's all about at the end of the day. Yeah. That's great. Okay, well, that was just one of the many ways that Teledyne Benthos acoustic modems are being used around the globe, providing highly reliable acoustic communications for all types of applications. If you'd like any more information on anything that was presented by Innovasea today, or information on any of our acoustic modems, if you've got an application in mind, we would certainly like to hear from you. Please feel free to reach out to me, and we will have some additional information that will go out in the email that will include the link to today's recorded webinar. So I don't see any questions coming up here. So I think we are, oh, let's see, let me just make positive here. If I got one more, oh, wait, I take that back. Got some coming in. Richard, here you go. How do you connect the tag to a fish?
Oh, that's a great question. So most of the tags are actually surgically implanted inside the fish. So external attachments, you know, in the early days were done, and invariably the fish would find a way to either rub it off, remove the tag, or it would get shed within a few weeks or months. So the preferred method is actually to surgically implant them inside the fish. So that means there's some surgery involved. So you catch a fish, you've got to anesthetize it, keep its gills aerated with water, and do surgery. So typically it takes a minute or two to do the incision, insert the tag, and suture the fish. So you are tracking that individual, and then you revive that fish and release it. Some animals, that's a little trickier to do, particularly great white sharks. Not too many people are ready to go and do surgery on great white sharks. But OSearch have come up with some interesting platforms. You may have seen them on the YouTube and such. And they tend to attach the tags externally, so they basically bolt it to, you know, when you've got a large animal like that, you can literally bolt it to the dorsal fin or attach it externally. The risk with external attachment, of course, is that the tag will get shed at some point. It'll either biofoul and that sort of thing. But yeah, generally surgically implanted, but we also have the option to externally attach the tags to the animals. Yeah.
Okay, great. And I've got two questions, one from Steve and one from Peter, and they're both asking about biofouling, which you just mentioned there, and how you cope with that on these devices. Can you give a little information on that?
Yeah, that's a challenge for sure, and we're certainly looking for solutions to that, particularly in shallow coastal areas where, you know, there's a lot more growth and so on. As you get into the deeper waters, particularly where the VR4s, if they get into several hundreds of meters of water, doesn't tend to be so much of an issue for us, but in the shallower coastal, more prolific areas of the water column, the biofouling can be an issue. A lot of times the receivers, need to be serviced either every 6 months or a year, depending again on the growth and concerns. But that's obviously something that needs to be watched and is problematic. We have scientists that have tried numbers of solutions, anti-fouling paints and so on, but those are not always environmentally friendly and are not legislated in parts of the world, particularly Europe and such. So different solutions, but it's a challenge. There's no question. Yeah, it is. That's a challenge.
Yeah, so I'm not surprised that question came up, because I think we all deal with that in our day-to-day. It's just sort of an ongoing issue. And you actually answered the second part of Peter's question there regarding periodic cleanings and so forth. So I know you touched on that. So you actually got 2 for 1 on that answer there. I think that is it for our questions. Let me just make sure I'm not missing. Oh, nope, got another one. Oh, no, same thing. Asking about biofouling.
Okay.
There we go. Yeah, I'm sure that is a concern for everybody on there. So, okay. Well, oh, one more just came up here. That's great. One from Hugo. How can we use an autonomous surface vehicle to track fish? Oh, good question.
Autonomous, certainly. We've sold a number of cabled receivers to different organizations that have attached them to vehicles, as well as VMTs, for example, on Slocums have been used. So virtually any autonomous vehicle can be equipped with a receiver, either cabled or fully autonomous, and it can collect presence or absence of tags in the vicinity. So the other advantage or potential advantage of these receivers, particularly those that are transponding, is periodically they emit a ping. So sometimes if a vehicle's gone missing, and we've had this happen where people have had the vehicle go missing, shall we say, and we're able to relocate it because the pinger was transmitting, and they were able to zero in back in on the vehicle. Yeah.
Nice. So you can find fish and vehicles.
Vehicle as opposed to a surface, but yeah.
Okay, great. Yeah, well, that is an interesting concept. We'll have to think about with our Ocean Science Z boat, because we've got that autonomous platform that's hadn't really thought about that. That's interesting to go that route. And let's see, here's another one. Is there, Joe Quinn's asking, is there a way to track animal movement in small areas? So he's saying specifically like lobsters, and it can be done real time.
Absolutely. So we continue to innovate in that space, and we're getting into smaller and smaller tags, which have higher resident frequencies. So they have, we have a 307 kilohertz system that we're about to launch. We've got the 180 kilohertz, which uses smaller tags. And with these smaller tags, our spatial ability to position spatially is quite good. I mean, we're well sub-meter in terms of spatial positioning of animals underwater. So in small areas, we have some studies that we're collaborating with on aquaculture facilities. So people know where the fish are. They're in the pen, or in some cases, they may be studying animals outside of pens. But again, looking at animal movement, animal behavior, particularly accelerometer tags on these animals, and measuring energetics. So this is all possible in fairly confined space. Lobsters on the bottom, there's been a number of lobster studies. Those are external, of course, and smolting, the molting will shed the tag, but at least you can study them for a period of time.
Okay, great. Well, we've got more questions coming in. This is super. So Ivan is asking, the towing receiver, is it a single hydrophone or an array? He's asking that to know if you can detect the bearing and elevation angles of tags and pings, specifically on the Wave Glider.
So on the Wave Glider, yeah, no, it's not a towed array in any shape. I'll just get back to it. So it just has a tower. So it's an omnidirectional listening receiver. and there's really no bearing or range information per se that we can get. We can at this time from those receivers, no. So there isn't that. But that is something that is being investigated.
Yeah, well, we can do range and bearing with the modems using our DAT. So we should talk a little bit more about that. That's an interesting idea, and might be something that we could collaborate on there as well. So yeah, good question, Ivan. Another question, in your opinion, what's the best method for tracking large marine species such as right whales?
Yeah, the right whales, that's another interesting problem. They've been done using acoustics for short term, but again, these tags, particularly 69 kilohertz, are probably in their hearing range. And so it's not generally used on mammals or used on right whales as such. And if they have been, I think Woods Hole has done some studies, but they were just, you know, a few days to a week kind of in duration, so they were actively tracking them. Tracking right whales is a challenge. I think certainly the passive acoustic monitoring, those that are using listening stations, picking up the whale songs and hydrophones in the water is, but attaching to whales is extremely challenging. Yeah, that's not an easy thing, and particularly you wouldn't want to do it with something that was in their auditory range. That's for sure.
Mm. Yeah, interesting. And that's, you know, such a species that really needs some protection right now as well. So yeah, big problem that hopefully someone can come up with a solution on that. I know we are doing some mammal monitoring with customers using our gliders and hydrophones, but as you said, you know, they're not necessarily tagged. It's just listening for their unique tones. So great question, Sarah. And David is asking, how much data are you tracking besides GPS, and what type of bandwidth does the compact modems provide for this?
So in terms of the compact modem, I believe we're running generally at around 1100 baud, so through the water column. When it comes to the tags transmitting, I mean, our baud rate is probably 1. So we're transmitting, you know, we're kind of like the Zigbee of underwater. We're very low data rates. We're sending sensor data, you know, updates maybe once every few minutes if there's sensor tags attached. So I don't know if I'm answering the question, but yeah, generally the acoustic telemetry system that we have is very low baud rate, and then of course once we get it into the VR4, we're able to utilize the Benthos modems much higher bandwidth to offload the data, and you know, we can typically get receivers offloaded in 15 to sort of 20 minutes, again depending on the number of detections that are there. But I don't know if that answers the question.
Sure. Okay. And David, if you have anything further on that, you know, reach out to us, and if we didn't fully answer that question for you, we'll be happy to do that. Okay. David said thank you, so I think we got him there. I think that is it for the questions. I know we're just running a little bit over here, but that was great. I am always excited to see questions at the end, and I learn things every single time we host one of these events, which is great. Hopefully everyone in the audience today learned something as well. And Richard, we'd like to thank you very much for presenting and giving us your time today. It was a really great topic, so thank you for that.
Great. Well, thank you. Thank you for the opportunity.
You bet, you bet. And for everyone that attended, thank you so much for your time as well. I know everyone's time is incredibly valuable, and we appreciate you spending a little time with us today to learn more about this application. Watch for the email with follow-up information, and as always, please do reach out if you would like any additional information. So with that, everyone, please have a great day, stay safe, and hopefully we'll see you online again soon. Thanks a lot.